Hi everyone, let's solve this problem. To sum, input array is sorted. Given a one indexed array of integers, numbers that is already sorted in non-decreasing order. So there are two things. One is one indexed, nothing but generally in programming arrays start from 0 index and they are expecting it to be one indexed. That means if it is 0, just return 1. That is all they are telling. And that is already sorted in non-decreasing order. Non-decreasing order is nothing but ascending order with duplicates, that's all. And find two numbers such that they add up to specific target. So they have given us a target and they are expecting us to find out two elements which sum up to the target. Let these numbers be numbers of index 1 and numbers of index 2, and the indexes lie between 1 and numbers dot length, because we are considering this as the index 1 and this will be numbers dot length as the index. Return the indices of the two numbers index 1 and index 2 added by 1 as integers index 1 and index 2 of length 2, which we have just discussed. The tests are generated such that there is exactly one solution. You may not use the same element twice. So we should not be using two elements again. Like I cannot use 2 and 2 or 7 and 7 to get the target. Okay. Your solution must use only constant extra space. So the space complexity should be big O of 1. That is already given. So now first let's try to understand the given constraint. Array is sorted. That is one constraint. One based index. And then what else? We have number 1 plus number 2 is equals to target. Then we should be returning index 1. Okay, numbers of index 1, or let's consider this as low pointer, and numbers of high. Then we will be returning low plus 1 comma high plus 1. This is because it is one based index. That's the only thing. So if the array is sorted, we are sure that if I keep moving, the numbers will be in the increasing order. So let me take these numbers and target. So if I keep moving, the numbers will be always in the increasing order 2, 7, 11, 15, because this is given non-decreasing order. So now let's say, for example, I take two numbers on both the ends, right? If I take the numbers on the both the ends, let's say low index is 0, high index is 3, but the number at that position will be 2 and 15. Now if I add 2 and 15, what will be my sum? Sum will be 17, which is greater than my target, right? So if my sum is greater than target, you understand that if I move my low pointer to next, what will happen? If I add 7 plus 15, it will increase more, right? Because this is a sorted order. But if I move the right pointer to the left, then what would happen? The number decreases. If the number decreases, sum will decrease. If sum will decrease, we will become close to the target. So basically, if I have to reduce my sum, I have to move. So if I have to reduce my sum, what I have to do? Move my high point so that it will balance or come closer to the target. Let's say I have to increase my sum. What should I do? Move my low point. But how do I know that if I have to reduce the point? If my numbers of low plus numbers of high is greater than my target, then I'll have to reduce my sum. If I have to reduce my sum, I have to move my high pointer to the previous one. in this, what will be the case here? Numbers of low plus numbers of high is less than target, right? If this is the case, what should we do? We have to increase the low pointer such that it will increase the overall sum. If it increase the overall sum, we will move closer to the target. So it's just that finding out I have a target. So if I move my low pointer, it will be increasing the sum, and if I move my high pointer, it will be decreasing my overall sum. So I have to balance between high and low. That is all. So now, since we understood this fundamental, now let's debug it. Low is equals to 0, nothing but 2, and high is equals to 3. The element at that position is 15. So my sum is basically 17 greater than my target 9. So what should I do? Reduce my sum. How can I reduce my sum? I will reduce my pointer. So in this case, what will happen? High will move to 2 and the value will be 11. So now again I'll calculate my sum. 2 plus 11 will be 13. 13 is again greater than 9. So what will happen? I will have to move again my high pointer to 1. The value at that place will be 7. In that case, sum is 9. Nothing but sum is equal to target. Then what will I do? I will be returning low plus 1 comma high plus 1 because this is a 1 based index. So now let's try to code it up. So let me define my pointers. My low pointer will be at the start point. My high pointer will be at the end point, because this is a sorted array. And I know that 0th index will have the minimum value and the last index will have the highest value. Now I will keep iterating over my array. I will just keep checking. So when you are increasing or decreasing the high and low pointers, you know that after certain point, like if your low is crossing your high, that means that you have already visited those elements before, right? You just have to visit the array such that, like, I am moving low from this side, if I am moving high from this side, I should meet at a midpoint. It cannot be that it can cross each other. So that is the use case. So that's the condition which we have to ensure that we are meeting at the midpoint or we found the answer. So now what will I do? I'll check numbers of low plus numbers of high. If it's greater than my target, what should I do? I should reduce my high point. If I reduce my high point, I will be reducing my sum value, right? Numbers of low plus numbers of high is less than my target. What should I do? I should be doing low plus plus. Else, what will be the else case? Like either sum is greater than target, either sum is less than target, or sum is equal to target, right? So in the else case, what should we do? We should return low plus 1 and high plus 1. Now we don't have to return anything from here because there is at least one solution for this problem. So it would definitely end up in this particular case, and it will always return. So let's try to run it. Now let's try to submit it. Cool, we were able to solve this problem. Now let's understand the time complexity. The time complexity is nothing but basically big of n, because we are iterating over all the elements. Even though we are using 2 pointers, we are just at max seeing all the element once using low or high pointer, right? If they cross each other, we are going to break the loop. So every element is only seen once, and the space complexity is constant time because we are not using any additional space, right? Thank you.